Good morning. Today we are getting into lesson 15.2 and 15.3, which is all about factoring quadratic trinomials. A quadratic means we know that it is degree 2, trinomial is 3 terms. So my quadratic trinomial usually looks like ax squared plus bx plus c, where a can't be equal to 0, because if a is 0, this whole term goes away and it's no longer a quadratic trinomial. So I have this quadratic trinomial where my a, b and c are some numbers. All right. So when we talked about factoring polynomials, we learned 3 different techniques. Today we are going to be learning the 4th technique for factoring quadratic trinomials. So when do I get a quadratic trinomial? I get a quadratic trinomial when I multiply a linear binomial and another linear binomial. Okay, so multiplying a linear binomial and another linear binomial gives a quadratic trinomial as a product. So let's take a look at an example. I have a linear binomial x plus 2 times 3x plus 5. It's linear because the degree is 1. It's a linear binomial. This is also a linear binomial. When I multiply the two linear binomials, I get this first step where I do the FOIL. I have x times 3x, 3x squared, x times 5 is 5x, 2 times 3x is 6x, and 2 times 5 is 10. So I get to the next step, combining like terms, 3x squared plus 11x plus 10. So I'm seeing that quadratic trinomial, which looks like ax squared plus bx plus c, where a is 3, b is 11, and c is 10. So I have my quadratic trinomial. So when we talk about factoring quadratic trinomial, we saw that factoring is reversing the multiplication process, right? So factoring a quadratic trinomial is reversing the steps of FOIL. All right, so we are going to reverse the FOIL steps. So the technique 4 that we are going to learn today is called A times C method. There are a lot of other methods people use to factor a quadratic trinomial, but I have found this method to be more convenient and easy to understand. All right. So I have this A times C method. So whenever I have a quadratic trinomial, I'm going to be using this A times C method. So as we talked about it yesterday, any factoring problem, the first step for me is to pull out a GCF if there is any, and then do whatever method that I'm using. Okay, so first technique always is to pull out a GCF. So let's take a look at what do I mean by reversing the steps of FOIL. Let's take a look at the same example that we had in the last page. I have x plus 2 equals 3x plus 5. I got this step after I did the FOIL. X times 3x, x times 5, 2 times 3x, and 2 times 5. I have all the terms I got after multiplying that. Then I combine the like terms. I get 3x squared plus 11x plus 10. All right, so this is the problem that we did earlier. So I'm saying that this is my product now, which is a quadratic trinomial. Now I want to reverse the process. Reversing the process, I am starting with my product, which is 3x squared plus 11x plus 10. So from here, I want to go to this step. That means when I look at it, my middle term, my 11x, my x term, I want to split it as 5x and 6x. But why only those two numbers? Why not any other number? Why has to be 5x and 6x? Only then we can get back our original linear binomials. All right. So I want to know how to figure out that number. Since I have this next to me, I know it is 5x and 6x. So just imagine that you never had that. You only started from there. Okay. So how do I know what two numbers that I have to use to split up my middle term? Okay. My b term. All right. So let's take a look at how I figure out those two numbers. For that, I need to multiply my a and c. That's why it is called A times C method. I multiply my a and c. So 3 times 10 is going to give me a 30. The sign of the number is also very important. So this is a positive 3 and a positive 10. So that's how I wrote positive 3 and positive 10. If it was a negative 3, we will be doing other problems that has negative signs also. You will understand then. All right. So now these two are positive numbers. So 3 times 10 is a 30. All right. Now the next step for me is to write all my factor pairs. Factor pairs means what are the two numbers that will multiply to give me a 30. There are different combinations that I can have, right? So 30 is a positive number. So when I multiply two numbers to give me the 30, both have to be a positive number or both have to be negative numbers. Then only I can get a positive 30 as my product. So I have the first combination is I can have a positive 1 and a positive 30. That will give me a 30. Or I can have a negative 1 and a negative 30. That will multiply to give me a positive 30. So the next number, positive 2 and positive 15, can give me a positive 30. Negative 2 and negative 15 can also give me a positive 30. Positive 3 and positive 10, positive 30. Negative 3, negative 10 is also a positive 30. 4 is not a factor of 30, so I'm going to go to the next number, positive 5 and positive 6. It will give me a positive 30. Negative 5 and negative 6 will also give me a positive 30. Now I have listed all the pairs that are possible for getting me a 30. All right. So this looks tedious in the beginning, but once you get into the pattern, you can recognize the pattern and you can straight away go to that particular pair that will give you the 30 if you multiply them, and it will give you 11 when you add the two numbers. So this is my factor pair. So I found out all the factor pairs. Now the idea here is when I add these two numbers, it should give me 11. Okay, so the product is 30. This is my sum. All right, the product should be a 30, but my sum of the two numbers should be a 11. So when I add these two numbers, I get a 31. When I add these two numbers, I get a negative 31. This is positive 17. This will give me a negative 17. This is a positive 13. This will give me a negative 13. This will give me a positive 11. This will give me a negative 11. So I'm looking that this is the promising one, right? This gives me a negative 11. So the pair that I'm interested in is the positive 5 and the positive 6, which is what we want, right? So if I want, what I'm going to do now is I'm going to take my original trinomial 3x squared plus 11x plus 10, and I'm going to split up my middle term because that's my next process in the next step in the reversing process. So I'm going to split it up as positive 5x and positive 6x. All right, so together I will get my 11x. So I'm going to rewrite it 3x squared plus 5x plus 6x plus 10. All right, so I have these four terms now. All right, so I went back, I reversed it, I gone back to that step. All right, now from here I want to get there. All right, so how do I get there? Now I have four terms, right? Since I have four terms, this is a polynomial with four terms, so I can use technique 3, which is factoring by grouping. So I group these, I group these. All right, so now what is the greatest common factor between these two guys? It's an x. So what's left of this term is a 3x. What's left of this term is a 5. Remember, I have to have the same binomial factor here also. So the common factor that I'm pulling out of these two guys is a positive 2. Now the common binomial factor is a 3x plus 5. And what's left is an x plus 2. So I started from here and I've got my two factors. If you look back at our problem was x plus 2 times 3x plus 5, which is what we have, x plus 2 times 3x plus 5. So whether I write it this way or this way, we know that it's one and the same because of commutative property of multiplication. These are one and the same. All right, so I started with my trinomial and I went back to my linear binomial factors. All right, so that's factoring a quadratic trinomial. So let's take another example. Say I have x squared plus 7x plus 12. I want to list my a, b, and c. Makes it easy for me. So my a is 1, b is 7, c is 12. So this is my product and this is my sum. My sum is always my b. So b is positive 7, right? The sign matters a lot. Always keep it with the sign. So my a times c is the product, which is 1 times 12. And sum is my middle term, which is 7. So I want to list all the factor pairs for 12. It's a positive 12. So the possibilities are positive 1 and positive 12 or negative 1 and negative 12. It's positive 2 and positive 6. See how I'm going in order? So that way you won't miss any of the factors. Positive 2 and positive 6. Negative 2 and negative 6. Positive 3 and positive 4. Negative 3 and negative 4. So now as and when the numbers get closer and closer, I'm exhausting all the pairs. So I have no more, right? So I have this. The sum of these two numbers will be a 13. The sum of these two numbers will be a negative 13. The sum of these two numbers will be an 8. The sum of these two numbers will be a negative 8. The sum of these two numbers will be a positive 7. And sum of these two will be a negative 7. So I want a sum of positive 7. So this is where my positive 7 is. These two are the numbers that I'm going to use to split up my middle term. So I have x squared plus 7x plus 12. So I split up my middle term as positive 3x and positive 4x. So I have x squared plus 3x plus 4x plus 12. So I've gone back to that step. Now 4 terms, group it. The common factor between these two is an x. What's left is an x plus 3. I want to have an x plus 3. So the number that I'm going to pull out of here is a positive 4. So my common binomial factor is an x plus 3. And what's left of them is an x plus 4. So I started with my trinomial and I got my linear binomial factors. So if I want to check whether I did it correctly, I told you I can check it by multiplying it back. So if I multiply it back, I will get x times x is x squared, x times 4 is 4x, 3 times x is 3x, and 3 times 4 is a 12. So x squared plus 7x plus 12. So I got back my original problem. So my factoring is correct. Alright, so that's another example. So I have another example. X squared plus 5x minus 14. Alright. My a is 1, b is 5, c is negative 14. Alright. So now again, a times c. Now it is 1 times negative 14. So the sign matters, right? 1 times negative 14 is negative 14. My sum is a positive 5. So this is my product and this is my sum. Alright, you can also call it a product sum method. Alright. So a times c is negative 14. Now my product is a negative number. That means the factor pair, one number should be a positive number and one number should be a negative number. Then only I will get a negative product. So the possibilities are positive 1 and negative 14 or negative 1 and positive 14. Either way I will get a negative 14. Positive 2 and negative 7 or negative 2 and positive 7. And that's about it. There are no other factors for negative 14. So my sum, positive 1 and negative 14 is going to give me a negative 13. Negative 1 and positive 14 is going to give me a positive 13. Positive 2 and negative 7 is going to give me a negative 5. Negative 2 and positive 7 is going to give me a positive 5. So my sum is a positive 5. So this is what I'm interested in. So I take my original x square plus 5x minus 14. I'm going to split up my middle term as negative 2x and positive 7x, my bad. Negative 2x and positive 7x. So I rewrite it x square minus 2x plus 7x minus 14. So together I'm going to get that 5x back. So I group it. The common is x minus 2. I have to have the x minus 2. So I pull out the 7, positive 7. So my common binomial factor is x minus 2, and what's left is an x plus 7. So my factors are x minus 2 times x plus 7. You can check your work by multiplying it back to see if you did it correctly. Let's take a look at an example where we have to pull out a GCF. So this is the polynomial, quadratic trinomial that's given to me. So my first step is always to pull out a GCF. Okay, always pull out a GCF if you have any. So when I look at this, between the numbers, my GCF is a 3. So I can pull out a 3. What's left is a 2x squared minus 7x minus 15. Alright, so as we said in our first lesson, that I will learn how to factor this, what's inside the parentheses also, right, after pulling out the GCF. Now this is a quadratic trinomial. So remember, I'm keeping the 3 aside. That's going to be part of my answer. So now I focus on 2x squared minus 7x minus 15. Now again, my product and my sum. My product is a times c. I'm going to list my a, b and c. Always do that. I forgot it this time. A is 2, b is negative 7 and c is negative 15. So a times c is 2 times negative 15, which is a negative 30. And my sum is a negative 7. Alright. So the factor pairs are positive 1 and negative 30, because it's a negative product, or negative 1 and positive 30. The next pairs, positive 2 and negative 15, or negative 2 and positive 15. The third pair, positive 3 and negative 10, or negative 3 and positive 10. Once you get to the pattern, you are already noticing something. So 4 is not a factor. Positive 5 and negative 6, negative 5 and positive 6. So the sum here is going to be a negative 29. The sum here is going to be a positive 29. The sum here is going to be a negative 13. The sum here is going to be a positive 13. This will give me a negative 7. This will give me a positive 7. This will give me a negative 1. This will give me a positive 1, right? What I'm interested in is the negative 7. So these two are the numbers that I'm going to use to split up my trinomial. So I have 2x squared minus 7x minus 15. I'm going to split it up as positive 3x and negative 10x. Alright, so let's go ahead. 2x squared plus 3x minus 10x minus 15. 4 terms, group it. So I have x that is common. So I have 2x plus 3. I have to have the 2x plus 3. And I'm seeing I have to pull out a negative 5. So my factors are 2x plus 3 times x minus 5. That's not my answer. Remember, I pulled out a 3 earlier. That's left there. So my final answer is 3 times 2x plus 3 times x minus 5. Alright. If you hadn't pulled out a GCF, if you hadn't pulled this out earlier, you would have either gotten a 6x plus 9 times x minus 5 or 2x plus 3 times 3x minus 15. One of those things would have happened. So that is not factoring completely. Remember, we said factoring completely means all factors should be prime factors. They cannot be split anymore. Okay. So if you hadn't pulled out the GCF earlier, you would have either gotten 6x plus 9 times x minus 5 or 2x plus 3 times 3x minus 15. This 3 would have been with one of those. As you can clearly see, this is not a prime factor because I could still pull out a 3 from here. As you can clearly see, this is also not a prime factor because I can pull out a 3 from there. So factoring it completely means all of your factors, whether it is binomial, trinomial, or a monomial, they should all be prime. It cannot be split anymore. Okay, so your binomial, trinomial factors, monomial, it could be a number that is 4, which is not a prime number, but your polynomial factors should be a prime factors. All right, so this is my answer. You can check it by multiplying them back. So that's about factoring quadratic trinomial. Your lesson 15.2 and 15.3 deal with factoring quadratic trinomials. The only difference between 15.2 and 15.3 is in 15.2, lesson 15.2, your a is kept as 1. In lesson 15.3, your a is any other number other than 1. Okay, so that's what the difference is. But other than that, both are quadratic trinomials and you can follow this method to factor them. Thank you.